In physics, the term light something refers to the electromagnetic radiation of any wavelength, wherever visible or may not be. In sense, it is nothing but an energy and it can propagate through vacuum also. It contains the wavelength which is transverse in nature. Light ray travels in straight line. If the peripheral conditions and the medium is not going to be changed with respect to time, then the light wave will always propagate in the straight path. There are several theories about light ray. Light ray sometimes is going to be considered as wave, but there is strong evidence that light can be treated as particle, and that is the logic. Light is going to be termed as wavicle. The light waves are the transverse waves in nature. That's why it requires no medium to be propagated, and as a result it can easily pass through the vacuum. The light waves are nothing but a kind of energy. The light waves are the electromagnetic waves, and this is also known as electromagnetic spectrum. The light waves can propagate through all the transparent mediums. The velocity of light ray is maximum in vacuum, and that is 3 into 10 to the power 8 meter per second. But the velocity of light ray slows down while it passes through the relatively optically denser medium. As an example, the velocity of light ray reduced in glass if we are going to compare it with the velocity of light ray in air, because the glass is the optically denser medium with respect to the air. Basically, in optically denser medium, the wavelength of the light ray decreases, but the frequency of the light ray remains same. Light shows several properties. Some of the properties support the wave nature of light ray, and some of the properties of light ray support the corpuscular theory based on it. But we are going to concentrate one of the wave property of light ray, and that is known as refraction. Now, the refraction is the phenomena due to which a ray of light deviates from its original path while traveling from one optical medium to another optical medium. Basically, the apparent bending of light ray while propagating through one transparent medium to another transparent medium is known as the refraction. The incident ray. A light ray traveling towards another optical medium is known as incident ray. Point of incidence: the point where an incident ray strikes another optical medium is known as point of incidence. Normal: a perpendicular drawn on the point of incidence is known as normal. Angle of incidence: the angle which the incident light ray makes with the normal is known as angle of incidence. Refracted ray: a ray of light which deviates from its path on entering in the other optical medium is known as the refracted ray. Angle of refraction: the angle which the refracted ray makes with the normal is known as the angle of refraction. Interface. Interface in physics is the surface separating two phases of matter, each of which may be solid, liquid, or gaseous. The interface may be a real boundary or may be a virtual one, which basically differentiates between two transparent medium. If the light ray propagates from optically rarer medium to optically denser medium, then after refraction it will move towards the normal, and when the light ray propagates from optically denser medium to optically rarer one, then after refraction it will move away from the normal. If we observe the first image, then we can easily realize that the angle of incidence is generally greater than that of the angle of refraction as the light ray moves from optically rarer medium to optically denser one. But for the second example, we can easily observe that the angle of incidence is genuinely less than the angle of refraction because the light ray is moving from optically denser medium to optically rarer one. The laws of refraction. There are two laws of refraction. Number one, the incident ray, the refracted ray, and the normal constructed at the point of incidence always lie on a same plane. Number two, the ratio between the sine of the angle of incidence and the sine of the angle of refraction is always constant for a particular monochromatic light ray and two definite transparent isotropic mediums. If we look forward in the adjacent figure, then the light ray is propagating through medium 1 to medium 2 and the angle of incidence is I and the angle of refraction is R. So, according to the law of refraction, for a particular monochromatic light ray and two definite transparent mediums, the sin I by sin R will remain constant. In the given case, the light ray is propagating from medium 1 to medium 2 and this can be expressed as the refractive index of medium 2 with respect to the medium 1 and this is going to be implemented as 1 mu 2. It signifies that the light ray is moving from first medium to second medium. That's why 1 has been written as superscript and 2 has been written as subscript. And one more thing that need to be considered that the angle of incidence I is greater than the angle of refraction. This signifies that the medium 2 is optically denser with respect to the medium 1 and as a result the velocity of light ray is maximum in medium 1 with respect to the medium 2. Now we are going to express the refractive index in a different manner. The refractive index of medium 2 with respect to medium 1, that is 1 mu 2, is going to be expressed as the ratio of the velocity of light ray in medium 1 and the velocity of light ray in medium 2. And as we have stated earlier, as the angle of incidence is greater than the angle of refraction, it can be easily stated that the velocity of light ray in medium 1 will be greater than of the velocity of light ray in medium 2. As a result, the refractive index of medium 2 with respect to medium 1 will be greater than 1. The absolute refractive index, the ratio of the velocity of light ray in the vacuum with respect to the velocity of light ray in the given optical medium is known as the absolute refractive index. Absolute refractive index is going to be implemented as V mu m, that is the velocity of light ray in vacuum by the velocity of light ray in the given optical medium. We know that the velocity of light ray in vacuum is maximum and this is evident that the V mu m will always be greater than 1. Now, if we inverse the total equation, that is m mu v, that is the refractive index of vacuum with respect to that particular optical medium, that can be implemented as the velocity of light ray in that given optical medium by the velocity of light ray in vacuum. So we can easily write that V mu m equal to 1 by m mu v. We are now proceeding for a very interesting part. The refractive index of medium B with respect to the medium A can be written as a mu B, and we know the velocity of the light in medium A by the velocity of the light in medium B is nothing but a mu B. Now we are going to divide the numerator as well as denominator with the part of the velocity of light ray in vacuum. So a mu b is going to be written as the velocity of the light ray in medium A by the velocity of light ray in vacuum by the velocity of light ray in medium B divided by the velocity of light ray in vacuum. So a mu b can be written as a mu v by b mu v because the velocity of light ray in medium A by the velocity of light ray in vacuum means a mu v, and the velocity of light ray in medium B with respect to the velocity of light ray in vacuum can be written as b mu v. Now we know a mu v equal to 1 by v mu a. So substituting the values, we can easily write that V mu B by V mu A is nothing but the A mu B.